They used to be called heavenly bodies. Our local star, prime mover of the earthly environment, father of all life. Our almost twin satellite, phasing predictably through the night. Small wonder both were regarded as gods by the ancients. Today we know the moon as a place. Now picture, if you will, a fantastic world where not one, but 12 moons crisscross the sky, 4 of them moving backwards, 4 others the size of small planets. This is Jupiter, largest member by far of the Sun's family, monarch of the outer planets, 1,000 times the size of Earth. In fact, twice as large as all the other planets combined. It is nearly a small star, a second sun, Jupiter, named for the Roman god of gods. To our eyes, it reveals only its dazzling cloud tops, rivers of wild color, and its trademark, the great red spot, a perpetual storm of unknown origin. On Jupiter, day and night are each less than 5 Earth hours long, and a man would weigh 500 pounds. In early 1972, mankind launched Pioneer 10, the first mission to the outer planets, the first to venture out beyond the orbit of Mars, out through the Jupiter system, and eventually out of our solar system completely. Share now the odyssey of the Jupiter pioneers. The planets of our solar system come in 2 varieties. The inner 4, including Earth, are heavy, rocky cinders. Where the 5th should be, there's only a band of debris, the asteroid belt. Beyond ride the enormous outer 4, the mysterious gas giants. Astronomers have studied them since the time of Galileo. It was he who discovered Jupiter's 4 large moons with his newly perfected telescope. Beautiful ringed Saturn. In 1979, Pioneer 11 will make mankind's first visit to Saturn, if it survives the rigorous journey of 6 years in time, nearly 2 billion miles in distance. Third of the gas giants, Uranus, rotating on its side, it circles the sun like a fallen gyroscope. And finally, Neptune. One of Neptune's moons, and one moon belonging to Uranus, were discovered by this modern Galileo, the late Dr. Gerard Kuiper of the University of Arizona. His backyard in Tucson has flowers, a swimming pool, and a private observatory. Here at Catalina Peak, his studies have produced some of the most outstanding color photographs ever made of Jupiter from the Earth's surface.
This is sort of a typical photograph which shows the red spot of the planet, which is the most prominent feature. This black spot here is the satellite Shadow. Is the satellite Io, which is the nearest of the 4 large satellites of the planet. The satellite itself is here and doesn't show very well contrasted to the planet itself. Now, the first thing you see is, first, of course, that the disk of the planet is elliptical. That is because of its rapid rotation, which is roughly 10 hours. The period is roughly 10 hours. The diameter of this planet is about 10 times the diameter of the Earth, so it is a gigantic planet. The total mass is not, however, 1,000 times. The volume is 1,000 times, but the mass is only about 300 times that of the Earth. So the mean density of this planet is somewhat like the Sun. And that is because it is largely composed of hydrogen. So the composition of this planet is very, very different from the Earth, and very similar, in fact, to the Sun, except the temperature, of course, is much lower than the Sun. And because the temperature is low, you get a chemistry here, which is totally different from the Sun. So you have all these interesting colors here, and what we have been doing in recent years is to try to understand both the motions of all these clouds and their composition.
Our odyssey to the outer planets begins here at Cape Kennedy. A good omen under a mock Jupiter sunrise. The ungainly, pregnant guppy delivers a special cargo. The Jupiter Pioneers were built by TRW Systems of Redondo Beach, California, under contract to NASA's Ames Research Center. The project involved some 25 million man-hours of meticulous work by the government, industry, university Pioneer team. Each marvelously compact and reliable spacecraft weighs less than 600 pounds, including some 65 pounds of scientific instruments. The 11 onboard sensors include 5 radiation and charged particle detectors, 1 magnetometer, and 3 light measuring devices. 1 for the visible spectrum and 1 for either end of the visible range, the infrared and the ultraviolet. There's also an experiment to look for asteroids and 1 to measure the number of times Pioneer is struck by space dust. All of these devices together use less electricity. 13 months later, a sister spacecraft, Pioneer 11, left the pad on its long and chancy voyage to Jupiter and Saturn. It's not easy to break out of the solar system. It requires enough speed to defeat the Sun's gravity as well as Earth's gravity. Pioneer streaks away faster than any previous spacecraft, gulping distance at 1,000,000 miles a day, passing the moon in just 11 hours. Still, Jupiter is nearly 2 years away. On the way out past Mars, the experiments are tested and calibrated. Their data add to mankind's understanding of the interplanetary climate of space. The asteroid belt, as some had imagined it. Before Pioneer 10, it was pictured as a region where great boulders grind together, creating a 40,000 mile-per-hour sandstorm. If so, it might have represented a perpetual barrier to outer planet flights. In fact, the pioneers found very little space dust in the asteroid belt. True, there are several thousand asteroids, some as big as Texas, but they should offer no menace to navigation. Pioneer gets its electricity from small onboard atomic heat sources. At 500 million miles, the sun is too weak to power solar cells. The spacecraft spins 5 times a minute for stabilization. On ground command, small thrusters fire to maintain the spin rate and to keep the large dish antenna precisely pointed at the receding Earth. This radio link is a two-way street. A constant stream of information flows back about the health of the Pioneer and its scientific observations. NASA's Deep Space Network tracks the mission. So sensitive are these ears that they will hear Pioneer out to nearly 2 billion miles and lose contact late in 1979. Pioneer is managed and controlled from Ames Research Center located at Mountain View, California, near San Francisco. The Nerve Center is in this building. Pioneer Project Manager Charles F. Hall.
So we're in the mission control area for Pioneer 10, and behind us is the mission control room. Now, right now they're preparing to send quite a few commands up to the spacecraft, merely to change the attitude of one of the instruments, the operating mode, so that we can look on Jupiter. The interesting feature here is that the round-trip light time, the time to get a message from here up to the spacecraft, and then to get a return answer is an hour and a half. So our people in there have to be used to this hour and a half delay when they start planning the mission.
Commander R10. R10. We just received the stat clear message. Roger. R10 Commando, verify command stack loaded. Block message number 9. First command, IP Whiskey 2, time 141032.8. Roger, copy. We're enabling message stand at this time.
The Pioneers are run by men who send commands from Earth, not by automatic systems on board. This cuts complexity and costs. During encounter, it's busy here. For example, to command just the electronic camera that makes pictures of Jupiter, Pioneer Control transmits some 15,000 commands in just 2 months. In response to these commands, the camera scans Jupiter's turbulent cloud tops as Pioneer spins toward encounter. Because the spacecraft is moving at up to 80,000 miles per hour, and because Jupiter is rotating at 22,000 miles per hour, the scans do not immediately form a pretty picture. They must be decoded and corrected for distortion. First, the scans are built up line by line on a television display. This gives a quick look at the operation of the system and a tantalizing hint of the spectacular pictures buried in the raw data. After the first stage of prettying up, Jupiter's first close-up portrait emerges. Late November 1973, 20 months after launch, Pioneer 10 closes in on Jupiter. Each hour brings the planet 20,000 miles closer. What lies below those inscrutable cloud tops? Could there be life in this maelstrom where pressures may reach 200,000 times Earth's? There are scientists who think that the answer might be yes, that deep in this raging atmosphere of ammonia, marsh gas, and helium, the self-replicating spark may have been struck. One believer is Dr. Carl Sagan of Cornell University.
Jupiter has an atmosphere rich in hydrogen and its compounds, the same kind of atmosphere that the Earth had at the time of the origin of life. So we think that the building blocks of life, at least earthly life, are being produced on Jupiter today, raining down from the skies like manna from heaven. And Jupiter may be a vast planetary laboratory in the chemistry of the origin of life that's been working for about 5 billion years. It's by no means out of the question that there are forms of life in the clouds of Jupiter. And indeed, if you viewed the solar system from afar, I think you could make an argument that life on Jupiter was more likely than life anywhere else, including on the Earth.
Dr. Sagan also provided for Pioneer the famous picture postcard to extraterrestrial life.
But in the remote contingency that there are interstellar spacefaring societies which might someday pick up this derelict, no longer radioing, we thought we would put a message on it to indicate a little bit of where we are, when we are, and who we are. We think that the information on where we are and when we are, indicated in this part of the message by the configuration of certain cosmic objects called pulsars, will be completely obvious to any society capable of traveling between the stars. These two objects will be more mysterious because it is unlikely that there will be human beings anywhere else, even though there may be other creatures elsewhere. And the practice served a very useful purpose in making us think about what sort of impression we might wish to give to the cosmos.
Each morning, the key scientific investigators and the key spacecraft personnel meet in the office of Pioneer Project Manager Charlie Hall for a stand-up meeting. Why not a sit-down meeting? Because, says Charlie, people don't talk so long when their feet get tired.
So like a contrast, I guess is a better word.
I have the impression that it is all in the fix. I don't know for sure that it is all in the fix.
Yeah, with such accuracy, but just grossly, whether we can trust the angles on the LCD.
I'm afraid to say anything because I don't know. I'll have to get to
say 250 degrees or something like that in System 3, which is not far from what the radio astronomers have inferred.
We have 3 sets of accurate observations with the IPP this week since the last precession maneuver.
What we're seeing here is that in for both electrons and protons, we're seeing in first approximation an in-phase change.
But don't you? Well, you're not pretty good. No, it's all right. You're going in pretty consistent. Yep.
December 2nd, 1973. Tomorrow, Pioneer will make its closest pass of Jupiter, when this fantastic world will fill 1/5 of the sky. Today, Pioneer is being cooked by incredibly severe radiation, yet everything continues to work perfectly. This spectacular picture shows the shadow of the satellite Io, just as Dr. Kuiper's ground-based photo did. But from this distance, new details in the cloud bands become evident. Huge coiling storm areas larger than the Earth. Since launch, Pioneer has been slowing down. Now the pull of Jupiter's gravity speeds it up to a fantastic 82,000 miles per hour. In effect, this crack-the-whip left turn gives Pioneer another rocket stage to fling it out of the solar system. Unexpectedly, the space dust count soars, 100 times as many hits. Jupiter's gravity may act as a cosmic vacuum cleaner. December 3rd. Pioneer sweeps to within 81,000 miles of the cloud tops. Now things happen fast. 15 minutes after closest approach, the spacecraft is targeted to pass out of Earth's sight behind the orange moon Io for a critical 2 minutes. This ultra-precise maneuver will use radio effects to reveal new information about Io, if the signal can be picked up again on the other side, and if Pioneer will obey commands again. Back at Mission Control, there's a maternity hospital atmosphere. They won't know what happened in space until 45 minutes later. The speed of light is much too slow for the anxious parents.
What kind of an illustration do you want to get? What kind of
future missions? We have observed the planet in the infrared. We've observed the planet in the ultraviolet. We require the actual probing of the atmosphere.
What did go behind you? Oh, we lost it? No, yeah, we went out of lock and we were less than 1 second from the plane.
And you're back. You're not back on.
No. Oh, it says that's an extra trajectory.
I'll give you the time in a second.
Oh, we missed the EO occupation by 1 second, and I was just sort of kidding him or telling him that you have to go through the ecliptic at the right time. When the EO goes in front of you, we're 3 Jupiter radii away, and EO 6 Jupiter radii. You got to get all this thing lined up, and we missed it by a second. Next time we'll do better.
An hour later, Pioneer passes out of sight of both Earth and Sun, this time behind Jupiter. The spacecraft is collecting its worst radiation exposure now. Tension is even greater this time. And so is the relief.
Norm, how was it? Very good. We came out just a little bit later than we expected to, about 40 seconds later than we expected to, but everything worked fine. We went in about 14 seconds later. All the instruments are operating just like they were when they went in. Came out exactly the same way. We're very pleased.
Gee, you're late again. It's pretty good for government work,
Makes it all worthwhile. It's after 10 years of having to put up with all these people, the 14 hours a day, it's all worthwhile.
Now Pioneer views a sight never before seen by man, the crescent Jupiter. From Earth, we can see only its full phase, like a full moon. These lighting angles give scientists new information. On the television system, the images rapidly become smaller. Now several consecutive pictures can be stored on the tube at once. Thanks to energy literally stolen from Jupiter, Pioneer 10 departs more than twice as fast as it arrived.
Early this morning,
Now the world wants to know, what have we learned?
And
The scientists readily admit to newsmen that for each question answered, 100 new ones have been raised.
Two different phenomena going on.
Project scientist Dr. John Wolfe reports.
Approximately 44 Jovian radii. We had the indication of very strange plasma distribution.
We're taking back with us to our laboratories data which essentially are puzzling to us and will take a long time to work out.
Some points are clear. The whole Jupiter system is heavier than we thought, by about the weight of 2 Earth moons.
Our most important finding to date has been
Io has a thin atmosphere. Thus, Jupiter's 4 large moons probably all have atmospheres.
Seeing relatively abrupt decreases in the field magnitude to much lower values.
A compass on Jupiter would point to the South Pole instead of the North Pole.
Through the magnetosphere.
The infrared experiment successfully mapped Jupiter's heat in fine detail. The planet gives off more than twice as much heat as it receives from the sun. Why? Possibly its enormous gravity makes it contract like a slow-motion star. The white belts are cooler, and therefore higher bands of clouds stretched around basically darker-colored material below. Also, the night side and the day side appear the same temperature. Discoveries like these flash out to the world. To experimenters, some of the most interesting findings concern Jupiter's radiation belts and magnetic field. Pioneer first broke into the magnetic field an incredible 4 million miles in front of the planet. Because of the pressure of the solar wind, this field streams out much farther behind Jupiter. Closer in, Pioneer indicates that Jupiter's intense radiation belts wobble up and down around a magnetic center some 10,000 miles from the center of the planet. In brief, Jupiter is much different from Earth and much more complex than researchers imagined. However, Pioneer proved that a spacecraft could survive the radiation. After encounter, the data tapes for the imaging experiment go to the University of Arizona for computer enhancement. In a meticulous process, millions of data points are juggled up and down the scale. And what emerges is a portrait of Jupiter to challenge the most imaginative artist. While Pioneer 10 journeys to the edge of the solar system and beyond, the information it returned has permitted Pioneer 11 to be redirected to not only pass closer by Jupiter, but to continue on to the next outer planet, Saturn. If all goes well, Pioneer 11 will reach the ringed planet late in 1979. And if it returns pictures, we will know much more about those glittering and mysterious rings. Mankind will continue to explore the outer planets, and sometime in the decades ahead, a robot explorer will descend on Io at the end of a solar eclipse by Jupiter. The sight will be one of the most dramatic in the solar system. During its hours in the freezing Jovian night, Io's atmosphere snows out onto the barren and radioactive terrain, then flashes back from solid ice directly into gas in the span of a few moments. The domain of the outer planets is majestic beyond comprehension. The pioneers, first to brave this land of giants, first to fly forever among the lonely and endless stars of our galaxy, carry mankind's message. We're on our way.